I'm just going to give like 30 seconds more here before we get started. Thanks for joining. Awesome. Vishal, you've already got us recording.
Yes,
Okay. And can one of you guys confirm that you can see my screen?
yes,
Beautiful. All right. Well, let's get going then. It's 2 minutes after the hour. So, welcome everyone to today's session of Multicloud Happenings. Thank you for joining at our new day and time. Going forward, this webcast will happen at this time on Thursdays to better accommodate our US West Coast attendees. We're excited today for today's episode, where the main topic is Oracle Zero Downtime Migration Utility, otherwise known as Oracle ZDM. And for that topic, we're joined by a guest presenter, Ricardo Gonzalez, who is a senior principal product manager for ZDM. But first, my name is Nathan Fuzi, and I'm joined by my colleague Vishal Patil, and we are product managers here at Oracle, focused on the Exadata database service and base database service, both in Oracle Cloud and in multi-cloud. Let's get started. Our safe harbor statement says that our discussion today and any future plans or dates we talk about are not a commitment and may not be incorporated into any contract. That said, if you have specific regional availability or feature or timeline asks, we'll be glad to work with you to help you plan. Reach out to your Oracle account team or contact an Oracle PM team directly if you have questions or requests. Okay, for today's session, I'm going to start with a short introduction to Oracle's multi-cloud offering and the services available, along with the latest multi-cloud service and region updates. And then Vishal is going to talk briefly about an ODB network peering update at Oracle Database at AWS. And then we'll turn it over to Ricardo to do a deep dive in Oracle ZDM, including how it works and specifically how you can use it to migrate your Oracle databases to any of the services in our multi-cloud offerings. As we go, please use the Q&A function to post your questions at any time. We'll do our best to answer them as they come. We'll also take time to review them and go deeper on them and our responses at the end of the presentation. Okay, first, what's Oracle Database Multi-Cloud? Well, Oracle has partnered with leading hyperscalers, including Microsoft Azure, Google Cloud, and AWS, to run Oracle Cloud infrastructure inside their data centers and to make Oracle Database cloud services available in their marketplaces. That physical co-location of infrastructure allows the multi-cloud offering to deliver extremely low latency and high bandwidth between the hyperscalers' native application services like AI, analytics, and containerized app services, and the Oracle database services. And that low latency is really key when you're talking about running mission critical applications. Another key aspect of the Oracle multi-cloud model is the integration of Oracle resources and services into the partner hyperscalers portal and APIs. And that enables you to provision, manage, and monitor the Oracle resources directly from your hyperscalers portal and automation. Now, what Oracle services are available? Well, there's Oracle Autonomous AI Database, which is cloud native and fully managed, running on top of the Oracle Exadata platform for extreme performance and availability. There's also the Exadata database service, which gives you the performance and scale of Exadata plus cloud automation while still giving you full administrative control. There's the base database service that offers a lower cost database for non-mission critical applications where you still need full administrative control. And the autonomous recovery service provides an efficient, fully managed backup solution that continuously validates your backups and provides backup security and immutability. And finally, OCI Golden Gate gives you a fully managed solution for high performance data integration and replication across heterogeneous environments. Here's the table of services available in OCI and each of our partner hyperscalers as of today. There have been no changes to service availability or planned launches in the past month. But as we've communicated previously, we do have plans to make exascale storage on Exadata database service on dedicated infrastructure, along with Oracle Golden Gate available on Oracle Database at Google Cloud in the coming months. We have recently launched two new regions for Oracle Database at Google Cloud, and those are Asia South in Delhi and Asia Northeast in Osaka, bringing us to 14 live regions with Oracle Database at Google Cloud. And we also launched three additional regions for Oracle Database at AWS this month, including Canada Central, EU West Ireland, and Asia Pacific Southeast Sydney, bringing the total Oracle database at AWS region count to 8. As always, if you're looking for any of the planned regions to be delivered on any specific time frame, please let your Oracle account team know. Please work with the product management team. And with that, I'll turn the mic over to Vishal to share another update. Vishal?
Thank you, Nathan. Hello, everyone. My name is Vishal Patil. I'm a product manager for Exadata Database Service and Multicloud Solutions. I'm going to go off the video because I'm seeing some bandwidth issues as I'm joining this webinar from a hotel room. Sorry about that, but hopefully you are able to hear me okay, Nathan?
Yeah, just fine.
Okay. All right. So we just want to make everyone aware of the new launches for Oracle Database at AWS, and specifically this time it's about the VPC. That means the application VPC and ODB network peering. Now, what ODB network is, which is a private isolated network, which has your Exadata VM clusters and autonomous VM clusters. It comes with the CIDR range for your client subnet, backup subnet for your VM clusters to use. And ODB peering is a user-created connection between your application VPC and your ODB network. Now, what we have announced recently is now you can have your multiple VPCs connecting to a single ODB network through ODB peering connections. Earlier, you used to have this kind of functionality through Transit Gateway or Cloud WAN, but only one VPC was allowed to ODB peer to one ODB network. That limitation has lifted now, and this is based on customer feedback. A lot of customers requested this. So now what we have is multiple application VPCs can connect directly to the ODB network and have that low latency connection between your application VPCs and ODB network, or the databases which are running inside the ODB network. On the other way, what we are also allowing is one VPC to multiple ODB networks. So if you have one application VPC, the right side of the slide, the right picture on the slide, where you have an application VPC which is connecting to multiple ODB networks. So that is possible as well. So with this, the limitation around not being able to connect multiple VPCs to a single ODB network, or one VPC to multiple ODB network, is lifted, and you can now have this configuration network topology as well. Next slide. All right, so some of the considerations and some of the information around the ODB peering. Apart from having one VPC connecting to multiple ODB networks, or multiple VPCs connecting to one ODB network, you can have multiple VPCs to multiple ODB networks. And the prior configuration of having multiple VPCs to multiple ODB networks via Transit Gateway or Cloud WAN is still possible. You can still utilize that. You can establish multiple peering connections from your VPC to different ODB networks, but you can only have one peering connection from that VPC to that one ODB network. You can have up to 45 peering connections to a single ODB network. Cider blocks cannot overlap, obviously, if you don't want to have routing conflicts. So the cider blocks cannot overlap between the ODB network and the peered VPCs. And the supernet cider blocks, that is like the all these the larger cider block encompassing multiple subnets are not supported in peered configurations currently. Now, customers or users who have created the ODB networks prior to this announcement, which was 7th February this year, and in North Virginia and Oregon region, they will have to recreate the ODB network. What that means is recreating ODB network means you'll have to recreate the VM clusters associated to those ODB networks. And this is only for the ODB networks which were created prior to February 7th, 2026. Now, with that, I'm going to hand it over to our special guest, Ricardo, to talk about the database migrations.
Okay. Um, Thank you, everybody. We just need confirmation from Nathan and Vishal that the screen that is being shown is the full screen.
Yes.
Correct. I will also apologize to everybody. There seems to be like a bandwidth issue and hence the pixelated screen, but I hope everything is fine now. Should be okay, right?
Your slide looks great over here.
Perfect. Okay. Well, thank you so much, everybody, for having me today. Michelle, Nathan, it's my pleasure to be here sharing a bit about ZDM. We'll have more in future for future releases. I'm going to focus right now on our current release, 21.5. Just as a way of introduction, my name is Ricardo Gonzalez. I'm the product manager for ZDM, and I work in the high availability and scalability team. So we oversee anything that has to do with MAA, maximum availability architecture. My team takes care of like the core foundation for all the database high availability, and of course the cloud services that rely on that high availability. So you have to work with DataGuard, RAC, ASM, ACFS, fleet batching provisioning, um, overall migration, anything that has to do with high availability, like we are here to help. And I'm happy to help you. And I don't have the answer, I'll know who will have that answer and help you with. So I'm just gonna start, make a brief introduction of what ZDM is, and then gonna like focus on actually how it works. And specifically for the cloud services that we have in Multicloud, I'll explain how and what are the preferred methods that we offer, how they actually work. Um, yeah, just to share some materials with you about the Oracle's main, focus for migration and overall like moving to the cloud. So just as a way of history, we started this work because there's always been some challenges of moving databases from point A to point B, right? Migration is not um, just click a button and then you have the database already in the other place. Plus, if you're moving to the cloud, there's other challenges that are part of it, right? So we started working, okay, what are the issues that people are seeing on a day-to-day basis and that we know we can address, right? So first of all, we had gaps, right? You might have people on DBA that are really good at certain tooling, the data that we offer for database overall administration and also for migration, but not necessarily for all of them, right? So you need to have knowledge in fully like data pump, recovery manager, Golden Gate if you're doing a logical replication, data guard for physical migration, also the cloud tooling itself, right? Which might new for a lot of folks. That was one of the gaps that we found. There's also security, right? Not every single database is fully enabled with encryption, right? Might not have TDE at source, right? Some folks don't have it on security, etc. So how we actually work with this gap in between unencrypted databases on premises and the different data centers that our customers have, and then the requirement for databases in the cloud to be fully encrypted, right? Then version management, right? A lot of the customers that we work with have an interesting fleet of databases that could go from everything 19C to some in 11.12.4, some in 12.1, some in 12.2, etc. So most clouds, especially now, right, you're seeing mostly only 19C databases, and then of course 26 AI. How do you manage that move, not only moving the database, but also working with the version management and required upgrades, and also depending on the underlying specific type of database, how would you help with that data that upgrade to be as seamless as possible? The other part is architecture. As you know, right, databases at Oracle, right, are especially now in the latest cloud services, is specifically multi-tenant configuration. That means container databases with one or multiple pluggable databases. But not all databases at source and in the different data centers that our customers have are specifically in the multi-tenant configuration, right? You might have older databases that do not have this feature. And also, it'll be also in more recent releases, even up to 19C, which might not be in multi-tenant, but you have to move them to a multi-tenant configuration. How do you change that, right? How do you do from a non-CDB database to a pluggable database? Um, Also, what about platform changes, right? We have a lot of customers that not necessarily are on Linux databases, right? They'll be on Solaris, AIX, and then we will talk more about other operating systems that are coming up. And you need to change them NDNS-wise because, of course, the target databases in the cloud are all Linux-based, right? So this adds another challenge into the migration like work. Finally, we're talking about licensing, right? I understand that, in the end of the day, there's of course cost to all the products that we use, right? So what happens if we encrypt, and then that means that we are using the advanced security? What happens if we're doing some compression in the backups that we're generating uh, for instantiation of the target database? Then when we use advanced compression, what about a golden gate, right? That has an extra cost. So all of this came into mind, and we started working. There's different teams involved in this, right? It's been a whole cross effort within the Oracle database organization. And then for the first time in late 2019, ZDM came about, right? The whole idea was to have a solution that would tackle all of the previous challenges in one single automator, right? Making it free, right? There's no cost to ZDM or the associated technologies. I mean, there's some restrictions, but overall it's free for all the technologies that we use. And we would like automate all the best practices of the tools that you saw before, right? So if a migration requires data pump, we'll automate it. If a migration requires a combination of Harman and DataGuard, same. Also for Golden Gate, et cetera, for the encryption part, compression, and so on and so forth. So we just wanted to have that in place so that it would be a standard and then used for other purposes within the migration suite at Oracle, right? So ZDM itself is also the main engine of the database migration service, which is a UI-based service that is native to the cloud, and it's for logical migration. But it can also be used for migrating to Exadata on premises, for instance, right? So we just wanted to have something that customers can rely on in a free way to streamline their fleet of databases. So if you have one database, that's okay. You might do the migration manually. It might just, you would need to learn a bit of the steps that are required, but you do it once. But our customers have 10, 20, 50, 100, 200 more databases, right? So you want to streamline as much as possible. So with that said, how do we work, right? ZDM is actually not a service. It's a binary that you download. It's extremely light. It's less than 1 gigabyte, and it's deployed on a virtual machine that can be actually running anywhere. Like we really don't have a restriction for where ZDM can run. Ideally, and what we do need is for it to have access to the source and target database and or any other component that is needed, right? So we have different ways of connecting. Originally we were like SSH based for physical migration, but of course we've grown to other ways of communicating with different components, um, SQLnet, and then of course we connect via HTTPS to the Golden Gate Hub, so on and so forth. So there's different configurations, and we have materials and step-by-step guides that I'll share at the end so that you can actually look into like what's needed depending on the type of migration you're doing. But we only need for those connections to exist. And again, in the materials that I'm going to share at the end, you can actually test and check and ensure that ZDM has those available. But there's no requirement for ZDM to be placed anywhere specifically, right? So you can run at a VM anywhere. It could be at a source data center, it could be at a target in the cloud, it could be on a dedicated VM anywhere else, right? I mean, I've done tests on a VM on a laptop, right? Because in the end, ZDM is not, there's no data going through it. We're not we don't ingest or process anything. We just orchestrate, right? And then I go to the second part of the slide. We're an orchestrator. Basically, we automate all the actions that need to be done. So we talk to the source database and tell the source, hey, you need to start like creating L0 and L1 backups in the case of Arman, right? Or hey, you need to do an export of this specific schema or a full export, etc. And we go to the target database and say, hey, like We're transferring these DOM files, putting them in a specific location, right, via data pump. I need you to do the import based on these DOM files, and so on and so forth. So basically, we have a set of stages and phases depending on the type of migration you're doing that we coordinate for you, and then ensure that everything went well, and then move to the next one. Now, these workflows are fully customizable. There's many ways for us to work, and I'll cover them in a bit. All the different, physical migration, hybrid migration, and logical migration, and they're customizable by you. So what we do is we work based on we're a command line based tool, right? We work based on a response file, and this file has a number of parameters. Now, these parameters basically tell ZDM what type of migration you're doing, right? So for instance, if you're doing a physical offline migration, what we're doing is creating Karman backups L0 and L1 and then transferring them to a backup location. So let's imagine we're going to BaseDB in OCI. We can use the object storage. We're going to, accelerate a cloud customer. We use NFS, multi-cloud as well. And I'll explain about the storage deployments in multi-cloud as well. And then ZDM will go to the target and say, hey, here are the backups. We're going to instantiate a target database and then ensure that, we're doing we'll encrypt, right? When we're restoring, we'll take care of registering wallet at the target, etc., and so on and so forth. For a basic migration, like I just explained, by the way, you need like 4 parameters. But it doesn't mean that we're that simple, right? We have ways of working, like we can set up the data guard broker, we can set up Golden Gate for you, etc. So for instance, just as an example, for physical migration, a basic migration have like 5, 6 parameters, but we have up to 100 options. For logical migration, it's almost up to 200 because we have to take into consideration data pump customization, Golden Gate customization, etc. And then we have a third flow called hybrid. I'll talk about that in a bit. But you have the control to set up and configure the migration as you please, right? So the whole idea was to just do what you would do normally as a DBA and in the steps of backups, synchronization, encryption, registration, switch, etc. But do it for you, right, in a customizable way. So we're not doing anything that you wouldn't do. We're just making it easier for you so that you can repeat it n number of times. Now, at the beginning, I said, hey, migrations are not easy or not just one click. Well, what we wanted to do, and the whole idea was to make it as close to that as possible, right? So if all the requirements are met, if all the connectivity exists, and if there's no hiccup along the way, you can actually perform a migration with one command, right? So we call it single button approach, right? So this is the command line interface that we offer called ZDM ZLI. Basically, what it would do is, you issue the command. If the response rate is correct and everything is available, we would take the migration from A to Z. It doesn't mean that migration cannot happen in a phased approach. So we allow for you to resume and pause at any given time. You can even tell ZDM, hey, I want to do a migration with DataGuard. I want you to do everything, restore the standby, and create a standby, instantiate a standby via restore on the target, set up data guard. But the moment data guard is up and running and we have reader logs being shipped from the source database on premises to my target in the cloud, I want you to pause. So the application will keep with the active workload on the source database. The read logs will still are going to continue to be shipped to the standby database, but use EDM wait. I don't want you to do anything only until I'm ready. Same for Golden Gate, by the way, right? We can automate the whole export of DOM files, import of the DOM files, set up of both microservices. So ZDM would actually create the extract and start capturing all the transactions and creating trail files, and then we will create a second microservice, right, as a replica to start applying the changes. And in that moment, ZDM pauses, everything keeps in synchronization, everything is active. It's just ZDM waiting for you to tell, hey, you're ready to continue. That way, we will allow our customers to say, well, we have a migration that is really important. We want to ensure that everything is in place. So we start Monday. We might have it 2 weeks running or 3 weeks running. It doesn't really matter. But it's gonna pause until we come to the sync phase, and then only when you're ready, right? Let's say Saturday at 3 in the morning when there's less, um, workload, or like you can take a bit of, we'll do now the switch. Then you can resume the migration. So we have that level of control of granularity. Well, you can schedule operations as well. You could say, I want my migration to go on a specific time. When I mentioned about ZDM running anywhere, by the way, on a dedicated VM with no specific requirements, we do have one small, which is basically the operating system. It has to be Linux, Oracle Linux 7 or 8, or Red Hat Linux 8 or 9. And then, of course, we ask for storage. We need 100 gigabytes of storage. That's a minimum requirement because we create a lot of logs. Every single operation that we perform gets logged. And we are, talking with a lot of components and also executing a lot of operations with both source and target database, right? So that's why we offer a comprehensive audit trail. One important thing as well is that I've talked about how we want to help you streamline your 10, 50, 20, 100, 200, etc. number of databases to be migrated. Because we are a command line based tool, what we do is we work in a jobs framework. That means that you issue a command for migration, we'll give you a job number. So the first time will be job 1, and then we work in the background. So ZDM will just like say, hey, well, job ID number 1 is running. What now? So you can issue more migration jobs and say, hey, well, now the second database, I want to do job number 2, and so on and so forth. Then you can query the specific number of job and also see the different logs as you want, but we can work in parallel, right? We've done, I don't know, 20 plus, even more databases at the same time, no issue, right? You just need to ensure that, the different components are available. And of course, if you're going to do, let's say, a Golden Gate based migration, that the Golden Gate allows for all the multiple microservices you're creating or have different deployments, and that's also valid as well. We are fully MA compliant, so we're part of the MA team, so we ourselves test the product, so it's fully within the MA best practices, right? As I mentioned, you can pause and resume at any given time. ZDM most likely, if you ask it to pause during a migration, which is also an option, right? You don't have to pre-program it to pause at the sync phase. You can also just say, hey, like I want to pause this job. Like ZDM will finish what's doing because we are like a phased approach. So that phase will finish, and then we'll pause the migration until you tell us to resume. We have an evaluation mode that we like, well, it's like a dry run, but it's called eval, that basically runs or tries to run as much as possible or close as possible all the minor steps for migration connectivity, check that all the requirements for all databases are in place, and it will let you know what could fail, right? We try to make it as close as possible, or of course there are things that could happen during the migration, and then we'll help you solve them. Then there is a specific and really important feature called user scripts or customizable user actions that basically allows for you to register scripts to run at the source or target level at the beginning or end of the migration in a couple of phases. And the reason for this, right, is because a lot of the customers that we have will have custom scripts that they use themselves and run, and they want to run at the source database or target database, or actions they want to run that we are not privy of, right? Like we won't have access to those. We don't know, right, that they exist, and we shouldn't, right? They're completely yours. But if you register the ZDM engine and provide the right permissions, then ZDM will be able to run them, right? That allows for the migration to be more flexible and also customizable to your end. Finally, we encrypt automatically the target, right? So for 12.2 databases and higher, if we're doing a physical migration, we use a wallet. So basically we use TDE. We ask you to like create a TDE wallet at source, and then we'll use it. We'll copy it and use it for encrypted restore at the target level. And then the database will be encrypted online. So there's no effect on that way for the target database. For logical migration with data pump, then that's automated, right? So basically, when we do the import that target, it will be encrypted anyway, and you're good, right? And TCDM takes care of that, and you don't have to worry about having an encrypted database in the cloud. Also, really important there is that we have the specific restricted licensing use, so that if for any reason there's any usage of encryption during the migration, there's no cost to you, right? We don't charge you. Like if you go to the database licensing guide right now, you'll see that for advanced compression and advanced encryption, ZDM, it's covered during the migration process. So that's really, 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 really cool. I want to stop super second, right? There's a couple of questions, right? It says here, logical online support reverse replication with source for fallback. We do not allow for that. We offer free Golden Gate, right? So there's no way for you to automate that Golden Gate like setup replicating back. If you were to own Golden Gate, if you have the Golden Gate license, please reach out to me and definitely we can talk about what options you have so that you can manually set up Golden Gate on the way back. But ZDM is a migration tool. We have a way for physical migration with data guard to keep up the data guard running, right? We're not using a active data guard or any license in that case. So, but for logical migration, that's not in place, right? And again, we're offering free Golden Gate with ZDM. It has like a restriction of like 183 days for the duration of the migration. So we can't offer and we don't automate that to fallback. I hope that makes sense. Now, in terms of support, we support databases, standard edition, enterprise edition. Of course, if you're using standard, there's some restrictions of the workflows that you can use. They can be hosted on premises or third-party clouds on unmanaged services. The only managed one that we support as source, it's RDS. So AWS RDS is supported for SVM. You can migrate out of it. Of course, also the autonomous database. So you're going to from autonomous to autonomous, ZVM supports that as well. Version-wise, we have 11.204 and higher. Some customers still ask about 11.203. We don't support it. The reason for that is there's several patch requirements that we need, especially for logical migration, that do not apply for 11.203, right? So this is like the version limitation we have. Like if you have databases that are previous to these versions, you'll have there are other tools that are manual that can help you. Now, platform-wise, of course, Linux is 100% supported. We have Solaris and AX, and we're working to introduce Windows as well in the next release, which we presented and talked about it in October in the last AI World. Target-wise, we don't do on-premises migration, by the way. We don't do Exadata on-premises, but we're working to include the Oracle Database Appliance. But if you try to run ZDM with an unsupported target, like it would fail. Like ZDM would know. Plus, we're offering a lot of like free tooling, so like it wouldn't be compliant, but it doesn't work, right? We're completely a cloud-based solution, so base database service, autonomous, both shared and dedicated. For next data, like the database cloud service, dedicated cloud customer, exascale as well, X on-prem, and of course, all the services that are available at Oracle Database at Azure, AWS, and Google Cloud are fully supported, and we have a lot of like step-by-step guides that cover those. Yeah. Okay. Now we have different workflows, as I mentioned, right? Our methodologies, there's 3 of them. Basically, we have, first of all, physical migration, and that's how we actually started our journey. So the first release of ZDM only had physical migration, right? We have an offline workflow that allows for us to do RMAN backup and restore, right? So basically, ZDM will connect to the source database, create their backups, then transfer them and to the target and perform a restore. Ensure that it's encrypted, register to the, with the DBAS or in cloud tooling, and then, finish the migration. That's great for like standard enterprise edition, and of course, use cases in which you do not have a downtime requirement. But if you want to do an online migration, like ZDM has different ways of working, right? So we can either go to the source and create backups, as I mentioned, L0 and L1, and transfer them. We can also do restore from service. So basically, we call it direct data transfer. The ZDM will connect to a source database, have it connect to a target, and instantiate a standby via restore from service, right? That will be an encrypted restore. So we do an encrypt and restore, and when the standby is already instantiated, we set up data guard for you. So now you have like a primary standby configuration. I'll explain the step-by-step of this, which is the main use case that we have in a bit. But that's how we work. You could also use a broker. So there's an option in ZDM that allows for you to set up the data guard broker here if you want for more control. And there's also an option that once we're done with the migration and we've performed the switch over and the application is not pointing to the cloud, ZDM will know to keep up shipping reader logs to that source, which is a standby. There's some implications here encryption-wise, but we'll talk about them in a bit. We also have standby database mode, right? That means that ZDM, if you have, let's say, a primary standby configuration at source, right? ZDM could also say, hey, well, if you, of course, like tell ZDM to do this via a response file, basically ZDM would know what the standby database is. We'll use that standby for the initial restore from service to the target database in the cloud. And then when ZDM is set in data guard, we'll use the primary. This is a way to have less intrusion on the source database. Some customers choose to do it, some don't, but it's an option that we have put in place for you. Then finally, for customers that have primary and standby databases in on-premises and want to have that in the cloud as soon as the migration is over, just because A, they want, B, because availability and how the overall architecture is in place, or C, because they have SLAs that say, hey, you always have to have a primary standby configuration. ZDM can now have, it's called Cloud Native Disaster Recovery, a way for us to create two databases in the cloud out of your initial primary. So we create two databases, a primary and a standby. You have to pretty much like provision them empty and associate them either manually for BaseDB or with data guard associations and a couple of other methods for extra services. But if you provide those two to ZDM, ZDM will understand that, hey, I'm going to treat them both as standbys. But once I perform the switch over to a primary, I know that there's a second database that I can then also switch and then take care of finalizing that broker relationship between the primary database in the cloud and the standby database in the cloud as you intended. So post migration, you'll have two databases. That's also an option that we have, and it's quite interesting for a lot of the customers that have that requirement to have in place an SLA for primary standby at all given times. Now, in release 21C, we introduced logical migration, and that requirement came because we needed to migrate, of course, to autonomous database. So we have two workflows there. We have offline, which again, it's we create data pump exports and then transfer them to a location and then do the import and create the target database. We can also use database links for smaller databases. It's not recommended for your large databases, but exists, right? And then we have the same, but for online migration. So in this case, we use Golden Gate, and I'll explain later how we have Golden Gate in place for you. There's different deployments, but we automate it for you, right? So you only have to provide ZDM, like the user authentication and overall URL where the Golden Gate hub is located. And then ZDM will go there and create all the microservices, extract, replicate, and take care of the replication. We have a lot of work that has been done in over the years for this integration between Data Pump and Golden Gate, because we understand that not everything is going to be replicated depending on data type restrictions, etc. So ZDM has different ways of working, right? You can do a full export, schema, object, etc. But also, we have different ways of working around any replication limitations. So we have modes like reload. So ZDM would do two exports: an initial export of all the supported objects that you wanna migrate. ZDM will do that, import the target database, and of course set up the microservices for only the exported objects, take care of the replication, and then upon switchover, and then now you have the application pointing to the target, and then Golden Gate has stopped. It has fulfilled his duty. ZDM will go back to the source and create a second export of all the unsupported objects. So we reload into the target database everything that you couldn't bring. So there's been a lot of work and development within our logical automation. Of course, even though this was born for the autonomous database as a target, it works for base and X as well. And this helps customers that want to do a seamless migration between an older version to a newer version. We've also automated it in physical, but there's downtime due to the final upgrade that we perform. In this case, you can actually go from 11 to 19 or 19 to 26, etc. And also for customers that are coming from different NDNs. So you're coming from Solaris or AX, this is a great use case. Now, based on that cross-NDNs, we also came up with an offline workflow for a lot of the customers that, especially cloud customer Exadata on premises, that didn't have that big of a downtime requirement, and basically they needed a way to automate cross-platform migration, right? So we do ARM and transport level spaces for data and data pump for metadata. We automate the whole process for them, but it's an offline migration, right? This we've done, a lot of customers that are, in older platforms, AX, Solaris, that are going to cloud customer. This is the perfect solution for them as long as their database specifically does not have that major requirement. Now, before I go into the step-by-step for both physical and logical, I want to show a bit of the overall picture of ZDM, the latest 21.5, right? Basically, this is pretty much what I've been talking and covering. You have, sources that are, on-prem, standard edition, and enterprise. We also like can migrate out of OCI. So any OCI service works as a valid target, sorry, source. And then same for like third-party cloud. So any like unmanaged database that you have deployed as infrastructure or any cloud, right? Or RDS, as I mentioned, AWS RDS, we can migrate with ZDM. And while I mentioned to you that we have several phases, they all resume or like summarize, sorry, in these specific like 5 phases here, right? About like readiness check, initial data transfer, ongoing sync, switch, and then evaluation and completion. It depends on the type of migration that we're using, right? That each phase will differ. But of course, if you go to our docs and you'll see that the actual number of phases for physical is like 20, like 22 for logical, so on and so forth, right? There are like, of course, more phases than that you have control and granularity. But in order to like paint a picture to you, this is how it looks. Everything that is here I've covered so far. The only difference is I didn't cover like backup locations, right? So for physical migration, we use the object storage. If you're migrating to, let's say, Clara customer and you have the recovery appliance, we also use that as a valid backup location. And when we use backups there, we also have NFS that is used for different use cases within multi-cloud and also for X on-prem and cloud customer. And for logical migration beyond the object storage and FSS for autonomous, and NFS, of course, as again, multi-cloud and other deployments, we allow for S3 buckets when you're coming out of RDS, right? So you're coming from RDS, S3 is a possibility to have all the DOM files as a backup location. And then, of course, the migration goes to a specific target, right? So, just to summarize, Exadata on premises, base DB, all the Exa, XACS, on-prem, cloud service, and cloud customer, autonomous, and then all the deployments that exist and all the services that exist at Azure Cloud, Google Cloud, and AWS. See one question here. Yep, perfect. We have, I'm gonna focus on physical migration, right? So how do we work and how will it be on a step-by-step basis, right? Imagine you have your source database that could be anywhere, as I mentioned. It could be third-party cloud, it could be on your data center, right? And you have ZDM running. In this case, for this like illustration, we have it on a VM running on the data center that you have, but it could be anywhere. Like again, there's no restriction, right? You'll download ZDM and configure it, ensure that everything is fine, and the response file with all the parameters to say, hey, I'm gonna do a physical migration is in place, right? So once you have that, right, you have to provision a target database that it's empty, but we need it as a placeholder in the desired service, right? So let's say Exadata at AWS or Azure or GCP, right? And you ensure that everybody can talk to each other. Once that's in place and you issue the migration command, you're going to tell ZDM, I want to migrate my database, right? Physical only migration. I don't want to use a backup location. I want to do it via restore from service. And when you have data card in place, I want you to pause. So basically ZDM connects to source and target, ensures that everything is in place, performs all the different pre-checks that we run. And then we'll connect to the source and say, hey, please talk to or connect to the target database and start doing a restore from service, right? And I also want you to perform an encrypt and restore for this target database. So, go ahead and do that. ZDM just queries until that is in place. And then once we're finished, right? And this, of course, this is probably the initial data transfer for any migration is what it takes a bit more. Once we're in place, we have an instance data standby, right? Of course, this is not fully online because while we're doing this, the application is still working on the source database. So we need to have a synchronization mechanism, right? That's when we have data card in place. So the CDM sets it up. As I mentioned, right, we have that for you. It could either be just regular data guard, or if you optionally have the broker, you can also do that as well. And here, as I mentioned at the beginning, ZDM will pause because you told ZDM to pause. But it could also be that you don't, right? And we continue. There's a lot of options here, right? We've worked a lot on customization, so you could actually do the switch over yourself if you wanted to, if ZDM is paused. And then when you resume the job, you tell ZDM, I please skip the switch over because I took care of it. That's an option. Some DBAs want to have that control. It's not necessary, but it could happen. If not, you just resume the job, and what ZDM does, it takes care of the actual role swap and the switch over. So now you have the application pointing to the target database in the cloud. And really important here, you could either do nothing, and then the next step is that we are gonna like clean up this data guard setup, or you could actually keep up the data guard connectivity and hence keep shipping reader logs to the source database in the cloud as a standby, in the cloud, sorry, on premises as a standby. But there's a caveat here, and it's really important to take into consideration, right? We when we do this, right? The target database now in the cloud, which is a primary, is encrypted, right? It has a TD, it's TD enabled. So all the read logs are going to be shipped to the standby on premises as well. So if for some reason you have a hybrid environment in which the initial database was not encrypted, right? That means that if you ever switch back, there's going to be a discrepancy there, right? There is a solution for this. We have a hybrid data card solution in place for 1916 and higher version of databases. Um, so I'm happy to share with at the end of the presentation on the chat, because I don't have it in the slides, but I have the link on how where we cover this. Like, this is an MA solution on what like work you have to do in the source and target database prior, so that it can handle that discrepancy. It's a temporary like setup, but it works for you in order to have a primary that is encrypted and a standby that is not, or the other way around. And it's quite helpful in the case you want to go back and forth, or you want to do some testing, etc. Right now, none of this is required, right? If you don't set this up, ZDM will just continue the migration. And what we do is we clean up the data card relationship. We execute data patch at the target, because I didn't mention, but you could actually have, let's say, a 1920 database at source and a 1928 at target, and that'll be fine, right? Like, ZDM will see that both are 19, right? They're both 19, and we will then run data patch at the end, so that any discrepancy that is there, like, we reconcile there, right? But you can also like skip it, by the way. Like, there's an option for you to not run it, or even retry it as any number of times if you want. Once that's all said and done, like, basically we verify that we're good, we clean up, and then we finish the migration. There's many other workflows for ZDM for physical migration, right? You can use, like, as I mentioned, creating the backups from scratch. We can do create into target databases, so we have a primary standby as well. We can do an upgrade, so ZDM can take care if you provide like two homes, like let's say 19 and a 26. There's a couple of like specific steps. Like, ZDM will migrate directly to the 19 to 19 with physical migration, and then upon switchover, perform either auto upgrade or the DBAS tooling, depending on the use case. We also have a conversion of a non-CDB to CDB. So let's say you're going to 12 to 12.2 or 19 to 19 from a non-CDB source to a CDB target. Like, ZDM will use the target home to create a temporary database that it's non-CDB, so that we can then do the whole data card setup without an issue. And upon switchover, we do an unplug plug operation. So you end up with a PDB within a CDB in the database, in the target database in the cloud. So the number of possibilities is quite high, but we want to automate it and make it as seamless as possible as so you can bring those databases there. Now, I know we're like running short on time, so I'm just gonna wrap up with logical migration. Just one small thing with logical that it's important is the Golden Gate licensing, right? If you're going to OCI, there is a database Golden Gate image called Golden Gate for Database Migrations, that basically when you go to the Oracle Cloud Marketplace, it's there. You accept the terms of use. I think it's like 183 days, so please review them, right? And it creates a compute node that has a Golden Gate deployment. So for any migration to OCI, that's perfect, right? You provide the credentials and all the information to ZDM. ZDM will connect to that compute that has the Golden Gate hub and create the required microservices. If you're going to cloud a customer, you still have to do this, but it wouldn't make sense for you to run the Golden Gate Hub in the cloud. So what we do is, in that compute node, there is in the file system a Docker container that you can download, right? And then use on your premises for your cloud customer migration. For X on-prem, you do require Golden Gate. It's like one of the use cases which we do not have free Golden Gate for you. And then for multi-cloud, which I know is probably one of the questions that you have, right now, yeah, you have to go through like approval process. So you have to reach out to me or the multi-cloud PM. Then we work with the Golden Gate team and provide like a private listing for you. But we have a container registry solution in place that will allow for you to download the Docker container. We're like finalizing testing the actual. So anyway, that's coming as a way for you to have not to go through the whole cloud marketplace solution, right? Having to download and then set up the Docker container at the target database in their new multi-cloud deployment. But we have step-by-step guides on how to do this specifically. So don't you worry. Like after the session, you can review them, and then if there's any question, I'm sure Nathan and Michelle can gladly share them with me. Now I'm gonna wrap up super quick on the step-by-step for logical migration, and then I'm gonna open up for questions, if that's fine. So based on what we saw for physical migration, let's say the setup is the same for logical. You have ZDM running on a VM, your source database, target database in the cloud. We wouldn't require backup location for the dump files. So OCI, it could be, again, FSS, OSS. And for multi-cloud, we have different deployments. So NFS basically on top of the different filing services that the providers offer. So it will be different for AWS than for Azure or GCP. But we have blogs in the MA blog that talk about each one of the multi-cloud providers and hyperscalers and what services we've certified to have NFS on top of those that work with file migration. But for now, think of an NFS solution, right? So, you create provide the Golden Gate Hub in OCI, as I mentioned, for multi-cloud and Docker container that you've provisioned. And ZDM like now knows where everything is, have the response file in place. So what we do is we do validation, SQLnet to the target database. We connect to the source via SSH, ensure that everything is fine. We'll go to the Golden Gate Hub and basically start creating the first microservice, right, which is the extract, and start capturing transactions from the source and storing trail files. Then what we do is we go to the source database and do the export as mentioned, right? It could be any level of granularity, so schema, object, table, full export, etc. Then ZDM goes to target database and say, hey, I want you to import from the export files that we've been creating, right? So please go ahead and do that so you can instantiate a target database. And once that is in place, we finish, like ZDM will go to a Golden Gate Hub and create a second microservice, which is a replicate. That replicate will apply transactions into the target database, right? And keep up. As I mentioned, for physical, you could pause here. And if not, like we have a set of best practices for switchover, but like ZDM will, ensure that there's no lag, keep up querying. And then when it's ready, just, basically continue the monitoring and then finally switch over, right? So this is somebody asked if we could switch back. Like we offer free Golden Gate, so there's no way for you to switch back with ZDM. You would need pay Golden Gate, and then it's not within ZDM, but like we can definitely talk for manual possibilities. But once we switch over, right, like we stop replication, etc., we clean up, ensure that everything is fine, and then exit the migration, right? So in this case, we're done. We have 5 minutes. So what I'm gonna do is just in 1 minute cover, just share with you. We have materials for all the multi-cloud deployments. So we have guides for physical and logical migration for all the EXA services, logical migration for all DBA autonomous database services, right? And for any like information that you want for like ZDM, right? Specifically all the materials and things that we do. Just you can go to the website that we have. So we have like a shortened version, like oracle.com/go/ZDM. There you have all the step-by-step guides, all the docs, etc. And you can, of course, always contact me. I'm more than happy to help with anything migration-wise that you may have. Yeah, so now we have 4 minutes for questions. Thank you.
All right, thank you, Ricardo. I think there's one unanswered question, which from KU Fisher saying, is exascale supported now? And I'm guessing that Exadata database service on exascale infrastructure
Yeah,
is as a
exascale is
target.
supported. Yeah, it's supported as the target for logical migration. So if you're going to exascale, logical migration supports it. If you're doing physical, it has to be to the 26, right? So basically, because physical is same version to same version, it's 26 to 26. You would have to have one 26 source. We're working on the 19 to 19 as well. That's part of that process. But right now, if you want to go to 19 and 26, you can use logical migration for it.
Awesome. Thank you. Are there any other questions? I don't see anything pending on the chat or Q&A. If there are any other questions, please feel free to post your questions on the chat or let me see. There is a raised hand. It just went off. Oh, there's a question, I think. Hold on. So there's a question. What about 10G R2 to XRCC? Is this possible?
Not with ZDM. Like there's a whole team led by Mike Dietrich that does like upgrades and migrations specifically. I mean, and they will have to do a manual migration, right? There's no automation that we can offer. We have a stop at 11204.
All right. There's one more question, which is any rollback in ZDM post switchback? I think it's similar to the previous question.
It's possible via physical migration. Like we would have, you could set up ZDM so that like we keep shipping reader logs back to the source database as a standby. ZDM exits, but you have a working data card configuration, right? So you can manage it as you want and then switch back and forth, like just roll swap. But the caveat here is that, as I mentioned, there's an encryption requirement for the target, right? So you will have if you have an encrypted source, you need to bear that in mind. There is a hybrid data card setup in which you have as I mentioned, an encrypted source and an encrypted target that can handle this, but you need to be 1916 and higher. For logical migration, we do not have that capability.
Okay. All right. I don't see any outstanding questions. So yes, to answer Samir, we are going to upload the recording to YouTube, and you will find this session as well as the prior sessions recordings there. All right, let me get the channel for that. Hold on.
Vishal, I just pasted the YouTube channel in the webinar chat.
Awesome. Thank you, Nathan. So that's the channel where we have the past recordings. And then for this session, you will have the recording in a couple of days available there as well. So if there are no outstanding questions, I want to thank Ricardo for joining us and giving this presentation on ZDM. But for the attendees, if you have any questions, please let us know. And then we can happily convey those questions to Ricardo and get answers for you. Thank you for joining. We are concluding today.